Welcome back to OK Calculus. This time we are continuing with particle motion. Last time I went over the basic particle motion questions, nothing too advanced, just finding the velocity at certain times, solving for t, and then solving for v of t. But this time we're going to try some new problems. Let's start off with a fresh problem here. So, the first problem, or shall I say new problem we got here is p of t equals t cubed minus 3t, and from watching the last video you should know that is the position at any time given, whether it's seconds or, and then the p could stand for feet. And then to give it a more real world context, we're gonna keep t. Oops. We're gonna have it so t must be greater or equal to 0, because you can't really have negative seconds. You can't have negative time. So I'm gonna keep it in real numbers here. Just want to point that out. So the first question is, when does the particle change direction? So that's a little bit different. It's probably a little new for you. But think about it. When something changes direction, it goes from a positive velocity to a negative velocity. What that means is that you could be running along this line, but in order to change direction, you got to stop and go back. And when you stop right there, your velocity is 0. So, basically what that means is we got to find the velocity and make it 0 and find when that happens. So let's find velocity. So v of t equals, using the power rule, 3t squared minus 3. And so we got to find out when that is 0. So let's make that 0 equals 3t squared minus 3. And now to find what makes this 0, what t value makes it 0, gonna have to do some old-fashioned factoring here. So we got if you factor out the 3, you get a t squared minus 1, which equals 0. And then that's not quite enough, so you can go 3t plus 1, t minus 1, using factoring, which I really don't need to explain, equals 0. And now you got your two values right here, t minus 1 and t plus 1. And so if you want to make this 0, you get t equals negative 1 and 1. But like I said, if you go back up here, I said t has to be greater than or equal to 0, so that automatically knocks that one out, so just 1. And so you got to check this as well, because maybe I was walking and I stopped, but then I kept going. So it doesn't always mean that you change direction when your velocity is 0. So we do have to check this. So let's make what we call a sign line. So you just make a little line, basically just charting what your velocity is. It's very simple. And so we found that at 1 our velocity was 0. So label this as v of t. And so we got to verify that this actually changes direction. So if you plug in anything below 1, let's try it. So try like a 0. If you plug in a 0 to v of t, you should get negative 3. So it's actually negative right there. The velocity is negative. And then obviously we know at 1 it is 0, but then if you go past 1, so I just plug in a big number like 10. So you get 10 squared, 100, 300 minus 3, that's positive. So you get a big old positive right there, which proves that you were going to the left, because negative velocity means you're going to the left, and then at t equals 1 second, you turned around. So we can say that at t equals 1, the particle changes direction. And now starting on a fresh piece of paper here, the next question. When is the particle's velocity positive? Now we kind of just did this with the sign line. Let me just redraw that sign line. So we had, boom, oops, It was 1, it was 0, and then it went negative and positive. So it was going to the left, and then at 1 second it turned around and started going to the right. And then it's asking when's the particle's velocity positive, so you're just looking for where it's positive, so right here. And then this goes all the way out to infinity. So you can say on 1, infinity. And if you ever had to explain why that's the case, you could say that is where v of t is positive. And then if it ever asks you where is it negative, obviously you look right here, but like I said, it can't be less than 0 because you can't have negative seconds. So you'd say, if you were looking for where it's negative, it'd be on 0, 1. And so, on to the next question. Is the particle's acceleration ever negative? Explain. So, this one's about acceleration, so none of this even matters right here. None of this matters. We're looking for acceleration. So, got to take the derivative of velocity to find acceleration. So, acceleration equals derivative of velocity. So, the derivative of 3t squared minus 3 is 6t, using the power rule. And so it's asking, is it ever negative? So as you can see, if you were to make a sine line of acceleration, this is acceleration. So as you can see, at 0, at t equals 0, it does change from negative to positive. But like I said, t can't be less than 0, so that doesn't even matter. So from everywhere on out, from 0, it's always going to be positive. Think about it. You plug in a 1, you get a 6, that's positive. Plug in a 2, get a 12, that's positive. So it's always positive. So it is never negative, at least on the interval from 0 to infinity. So if you had to explain it, you could say that is where a of t is positive. Because a of t is positive, the acceleration is never negative. Alright, just like to thank you again for watching this. This is just kind of a part 2 for the particle motion. Just more in-depth questions. So hopefully you know how to find when a particle changes direction, and how to find when a velocity is positive or negative, as well as how to find acceleration. See you next time.